You want this portion only. This much is not needed. Yeah, why? Full board it is not needed.
Okay, very good morning, children. So we are going to start the language of chemistry today. Language of chemistry topic. Language of chemistry topic. So in this language of chemistry topic, the most important one is nuclide atom notation. Nuclide atom notation. Nuclide atom notation. Okay. Generally, in the coming classes, you will learn about each and every term. But first, what is notation? What is notation? What we call it as notation is it's a representation, symbolic representation. Okay, it's a symbolic representation. Okay, atom means what is atom? So the smallest indivisible particle. The smallest indivisible particle of matter which takes part in a chemical reaction. We call it as atom. Okay. So now nuclide means nucleus. So now when it comes to chemistry, nuclide atom notation, the first letter in English alphabet is what? A. The last letter in the English alphabet is what? Z. Any unknown thing in mathematics, how you will represent it with what symbol? X. So this XEAZ is called as nuclide atom notation. This is nuclide atom notation. Nuclide atom notation. We call it as nuclide atom notation. Nuclide atom notation. We read it as how we will read it? X A Z. We read it as X A and Z. We read it as X A Z. Okay. Now X A Z. What is X and what is A and what is Z? X represents symbol of the element. X represents symbol of the element. And A represents atomic mass. A represents atomic mass. And Z represents atomic number. So after M, N will come. No need to confuse. A and Z. What is A and what is Z? No need to break our head. Straight away. Atomic mass and atomic number. And after M, N will come. So mass number. X, A, Z. Is it clear? Any doubts? Right. Now you can note down. So now we have X, A, Z. X is the symbol of the element. Now, in the atom, subatomic particles are there. So many atoms, subatomic particles are present. What are those subatomic particles? Okay, subatomic particles. In that we have fundamental particle. Fundamental particles are, we call them as fundamental particles. What are the fundamental particles? What are the fundamental atomic particles? Fundamental. So fundamental particles in atom are three are there: electron, proton, and neutron. These three are the fundamental particles: electron, proton, and neutron. These three are the fundamental particles in an atom. Okay, electron means electron, negatively charged particle. Negatively charged particle. Proton, positively charged particle. Positively charged particle. Neutron, no charge. Neutron is having no charge at all. So once again I am repeating C. So XEAZ means X is the symbol of the element, A is the atomic mass, and Z is the atomic number. Electron, proton, and neutron are called as the fundamental particles in an atom. So electrons are negatively charged particles, protons are positively charged particles, neutrons are no charged particles. So now, how many electrons are present, how many protons are present, how many neutrons are present? Calculations. So, calculation of electron, proton, and neutron in a given atom. How to calculate? How you can calculate that? Number of electrons, protons, neutrons in a given atom. So number of electrons in X is equal to Z. Number of neutrons in X is equal to A minus Z. Number of protons in X is equal to Z. Okay. Suppose if you have helium 4-2, how many electrons are present in that? According to this, number of electrons in helium equal to Z. Z is how much here? 2. So number of electrons in helium are how many? 2. Next, number of neutrons in helium. 4 minus 2. It is 2. Number of protons in helium. It is Z. It is equal to 2. So this is the formula of the calculation of number of electrons, protons, and neutrons in an atom. Any doubts?
So can you explain it again?
Which one?
This one.
Electron and protons. Suppose let us consider sodium 2311. I need number of electrons in sodium. of electrons in sodium, I mean. Number of electrons in sodium. How many? 11. Why? It is equal to Z, Z equal to 11. Next, number of neutrons in sodium.
23 minus 7.
Neutrons in sodium. How much it is? A minus Z. That is 23 minus 7. How many? 12. Next, number of protons in sodium. How many? Z. How many? 11. So number of electrons and number of protons are same in neutral atom. In a neutral atom, number of protons is equal to number of electrons. Okay? Any doubts? Have you understood now how to calculate? Right. You can note down. So we use the word neutral atom. Means what? No charge on it. Okay? So this no charged particle. Okay? Charged particle and no charge. There is a lot of difference. So when an atom will become a charged particle, so we call it as ion. We call it as ion. When an atom will become an ion. So when an atom will become ion. When an atom will become ion. So what? When an atom losses or gains electron or electrons, then it attains certain charge. That charged particle is called ion. Is called as ion. Okay. See, when an atom losses or gains electron or electrons, then it contains certain charge. That charged particle is called as ion. Okay. So ions are again two types. You clearly observe what I am writing. Clearly observe. Ions are two types. You see here, I am using the symbol cat. Anion. The symbol is there very clearly. Cat T. And so positive ion and negative ion. Is it right? Positive ion. And negative ion. So we have two types of ions. One is a positive ion and one is a negative ion. Positive ion is called as cation and negative ion is called as anion. Then when an atom becomes cation and when an atom will become anion. So in general knowledge, in our general life, what we use gain, for what purpose we use the word gain? Gain means take it. chemistry it is opposite. It is code language. So when an atom will become cation? When it loses the electron. See here, when an atom losses electron or electrons, then it attains certain positive charge. That positively charged particle. That positively charged particle is called cation. Okay. Next, what is anion? When an atom gains electron or electrons, then it attains certain negative charge. That negatively charged particle is called as anion. Now you see me, Na plus and Mg2 plus are there. Whether it is a cation or anion? Cation. How many electrons are gained or lost here? One. How you will read this? Sodium lost 1 electron. Magnesium lost 2 electrons. Cl minus means chlorine gained 1 electron. Oxygen gained 2 electrons. Have you understood now? No doubt. Hope now you have understood what is an atom, what is nuclide atom rotation, next how to calculate protons, electrons and neutrons, and what is an ion, and what are the types of ions, that is what is a cation and what is an anion. So these are the basic fundamentals what we have discussed now. Now we will enter into the elements. Okay, so how to learn the elements, that I will give you one technique. Hydrogen H11, helium He42, lithium Li73, beryllium Be49. Next, boron B511, carbon C126, nitrogen N147, oxygen O16H, fluorine F99, neon Ne2010, sodium 23 11. Magnesium Mg 24 12. See, up to 12 elements I have written on board now. Suppose, what is the symbol of hydrogen? What is the symbol of hydrogen? H. What is the symbol of oxygen? O. What is the symbol of sodium? Na. How many electrons are present in lithium? Direct Z 3. How many neutrons are present in hydrogen? 0. 1 minus 1, 0. So, if you know this and you have to by heart these all 1 to 20 elements only. I am asking you to by heart only 1 to 20 elements in the form of nuclear atom notation. You will get number of electrons, you will get number of protons and number of neutrons. Apart from this, you know how what is the symbol of that particular element. So once again, how to read? I am saying hydrogen H11, helium He42, lithium Li73, beryllium Be94, boron B115, carbon C126, nitrogen N147, oxygen O168, fluorine F99, neon Ne2010, sodium Na2311, magnesium Mg2412. Okay, you note down this in your notebook now. So we have written up to magnesium. After magnesium, aluminium. Al2730. Silicon. Si2814. And phosphorus. P3115 and sulfur S3216, chlorine Cl35.5 70, argon Ar4018, potassium K3990, calcium Ca4020. So 1 to 20 elements you have to learn like this only. Hydrogen H11, helium He42, lithium Li73. Okay, like this up to 20 you have to complete. Okay, in the previous I have written up to magnesium. Now aluminium Al2713, silicon Si2814, phosphorus P3115, sulfur S3216, chlorine Cl35.5 17, argon Ar4018, potassium K3919, calcium Ca4020. Okay, you note down this. So in today's session, under language of chemistry part 1, we have discussed about what is an atom, nuclide atom notation, fundamental particles of an atom, and calculation of number of electrons, protons, neutrons. We have that. And next, in HCAZ form, that is nuclide atom notation, 1 to 20 elements. List we have given you, and later that what is an ion, types of ions, when an atom will become cation and when an atom will become anion. Okay, and the last question from my side for you to end this class is, how many electrons are there in Na plus? How many electrons are there in Na plus? See, how many electrons are there? How many electrons are there in Na plus? Na plus, how many electrons are there? How we will get this? How we can calculate how many electrons are there in Na plus? We all know that sodium means Na23 level. Here Z equal to how much? 11. A equal to how much? 23. So number of electrons in Na plus is equal to, plus means how much actually it has lost. How many electrons it has lost? 1 electron. How many are there actually? 11. It has lost 1 electron. Means total how many? 10. So what is the answer now? 10 electrons are present in 10 electrons are present in Na plus. Have you understood? One more question to you now. How many electrons are there in O2 minus? So O2 minus means what you have to get again? Oxygen. O16H. So how many electrons are lost or gained here? O2 minus means how much? Gain or lost? Gain. So here already 8 electrons are there. 2 are gained. Means how many? 8 plus 2? 10 electrons are gained. So 10 electrons are there. 10 electrons are present in O2 minus. Any change in neutrons? No change at all. Any change in protons? No change at all. Why? We had the discussion of ion only with respect to electrons only. When an atom will become an electron ion, when it gains or losses electron or electrons. Is it or not? So that's why there is a change only in electron number. There is no change in the proton number. There is no change in the neutron number when an atom becomes an ion. Okay? So there is no change at all. That you should keep in your mind. And for this, with this we will stop the class for today. Any doubts?